Mars. This celestial neighbor, the fourth planet from our sun, has captivated human imagination for millennia. Its distinctive reddish hue, a consequence of iron oxide on its surface, earned it the moniker the Red Planet. From early astronomers to modern-day scientists, Mars has held a unique place in our collective consciousness. Ancient civilizations wove tales of gods and monsters around its fiery glow, while today we envision a future where humanity might one day call this distant world home. The allure of Mars lies not just in its proximity. It is, after all, one of Earth's closest planetary neighbors, but also in its tantalizing potential. Could life, even in its most rudimentary form, have once existed on this now arid planet? These questions fuel our desire to unravel the mysteries of Mars. The human fascination with Mars predates the invention of the telescope. Ancient civilizations, observing the night sky with keen eyes, noted its distinctive reddish color and erratic movements. Unlike the other wandering stars, Mars seemed to change direction in its celestial path, sometimes moving forward, other times appearing to loop backward in a phenomenon known as retrograde motion. These early skywatchers wove intricate myths and legends around the red planet, often associating it with war and conflict due to its blood-red color. The Babylonians called it Nergal, their god of death and pestilence, while the Romans identified it with Mars, their god of war. Despite the ominous connotations, these early observations laid the groundwork for our scientific understanding of Mars. It was not until the invention of the telescope in the 17th century that our understanding of Mars began to shift from myth to science. Galileo Galilei, the father of modern astronomy, was among the first to observe Mars through this new instrument, though his observations were limited by the rudimentary technology of the time. The mid-20th century marked the dawn of the space age, and with it the beginning of our robotic exploration of Mars. No longer content with observing the red planet from afar, humanity set its sights on sending spacecraft to unlock its secrets. In 1965, NASA's Mariner 4 spacecraft made history by conducting the first successful flyby of Mars, beaming back to Earth the first close-up images of another planet. These grainy images, revealing a cratered and barren landscape, shattered the prevailing notion of Mars as a lush, Earth-like world. Subsequent Mariner missions, including Mariner 6, 7 and 9, further expanded our understanding of the Martian surface and atmosphere. The Viking missions of the 1970s represented a bold new chapter in Martian exploration. These ambitious missions consisted of 2 orbiters and 2 landers, designed to not only image the Martian surface, but also to search for signs of life. While the Viking landers failed to find conclusive evidence of present-day life, they provided invaluable data about the Martian soil, atmosphere, and the possibility of past liquid water. These early missions laid the foundation for our modern understanding of Mars. While orbiting spacecraft provided invaluable data about Mars, it was the deployment of rovers on the Martian surface that truly revolutionized our understanding of the Red Planet. These robotic explorers, equipped with advanced instruments and capable of traversing the Martian terrain, allowed us to study the planet's geology, climate, and potential for life in unprecedented detail. The first successful Mars rover was Sojourner, a small 6-wheeled vehicle that landed on Mars in 1997 as part of NASA's Pathfinder mission. Though operational for only a few months, Sojourner demonstrated the feasibility of roving exploration on Mars, paving the way for more ambitious missions. In 2004, NASA landed twin rovers, Spirit and Opportunity, on opposite sides of Mars. These rovers, far more capable than their predecessor, embarked on epic journeys of discovery, exploring craters, canyons, and plains. Both rovers far exceeded their planned 90-day missions, with Opportunity operating for over 14 years. Their observations provided compelling evidence that liquid water once flowed on the Martian surface, suggesting a warmer, wetter past. Section 5, Unforgiving Beauty. The Martian surface and atmosphere. Mars is a planet of stark contrasts, its surface a tapestry of rugged beauty and desolate grandeur. Vast plains of reddish dust stretch towards the horizon, punctuated by towering volcanoes, ancient impact craters, and deep canyons that dwarf anything found on Earth. This alien landscape, shaped by billions of years of geological processes, tells a story of a planet that was once more Earth-like, with flowing water, a thicker atmosphere, and perhaps even life. One of the most striking features of the Martian surface is Valles Marineris, a system of canyons that stretches over 4,000 kilometers long, 200 kilometers wide, and up to 7 kilometers deep. This immense canyon system, named after the Mariner 9 spacecraft that discovered it, is thought to have formed by tectonic activity early in Mars history. Another prominent feature is Olympus Mons, a shield volcano that rises 21 kilometers above the surrounding plains, making it the tallest mountain in the solar system. Olympus Mons is a testament to Mars' volcanic past, a time when molten rock flowed freely across its surface. While Mars' surface is undeniably captivating, its atmosphere is thin and unforgiving. Section 6, A Martian Dream: The Challenges and Possibilities of Human Settlement. The dream of humans one day walking on Mars, of establishing a permanent presence on another planet, has captured the imagination of generations. While significant challenges remain, advances in technology and our growing understanding of the Red Planet bring this dream closer to reality. One of the most significant challenges of human missions to Mars is the long duration of the journey. A round-trip mission to Mars would take approximately 2 to 3 years, exposing astronauts to extended periods of microgravity, cosmic radiation, and psychological stress. Developing spacecraft and habitats that can provide adequate protection and support for astronauts during this extended journey is crucial. Once on Mars, humans would face the challenge of surviving in a hostile and unforgiving environment. The thin atmosphere provides little protection from solar radiation, requiring the development of radiation-shielded habitats. The lack of breathable air necessitates life support systems that can generate oxygen and remove carbon dioxide. Despite these challenges, the potential rewards of human exploration and settlement of Mars are immense. Section 7, To Boldly Go: Future Missions and International Collaboration. The quest to explore Mars continues unabated, with multiple space agencies and private companies planning ambitious missions to the Red Planet in the coming decades. These missions aim to build upon the knowledge gained from previous explorations, delving deeper into the Martian past, searching for signs of life, and paving the way for human exploration. NASA's Perseverance rover, which landed on Mars in 2021, is currently searching for signs of ancient life and collecting rock and soil samples to be returned to Earth by a future mission. This sample return mission, slated for the 2030s, would provide scientists with an unprecedented opportunity to study Martian materials in Earth-based laboratories. Beyond Perseverance, NASA is also developing the Artemis program, a multi-phase endeavor that aims to return humans to the Moon by the mid-2020s. The Artemis program is seen as a stepping stone to Mars, providing a proving ground for technologies and operations that will be crucial for human missions to the Red Planet. International collaboration is also playing an increasingly important role in Martian exploration. Section 8, Conclusion: The Enduring Allure of Mars. From the musings of ancient astronomers to the cutting-edge rovers exploring its alien terrain, Mars has held an enduring allure for humanity. It represents the ultimate frontier, a testament to our unquenchable thirst for knowledge and our desire to push the boundaries of what's possible. The Red Planet, once shrouded in myth and speculation, is gradually revealing its secrets, offering tantalizing clues about its past and the potential for life beyond Earth. As we stand on the cusp of a new era of Martian exploration, the dream of unlocking the mysteries of Mars feels closer than ever before. The journey to Mars is not merely about reaching another planet, it's about understanding ourselves, our place in the cosmos, and the extraordinary potential that lies within us to explore the unknown.